In this video, we're going to do a series of exercises uh, in Python focusing on decision structures. And our first exercise is a calories burned program that doesn't actually accept any input from the user. It just outputs a list of information, and we'll do that using a loop. So I'm going to create a new file. We'll call this E1 underscore calories burned, not py. Okay. Running on a particular treadmill burns 4.2 calories per minute. Write a Python program that uses a loop to display the number of calories burned after 5, 10, 15, 20, 25, and 30 minutes. Alright, so let's just jump into this. Let's print out the program's purpose. This program calculates the number of calories burned in 5-minute intervals. And we'll put a new line character at the end of that string to get some separation in our loop here. Alright, let's create a constant for our 4.2 calories per minute. And I'm just going to call it calories per minute. I guess I probably should call it calories burned per minute. We'll set that equal to 4.2, and that's going to be our first constant. We might have some more, but definitely that one. Anytime you know how many iterations you're going to have of a loop, that kind of prescribes the use of a for loop. Now, that's not to say that we can't do a while, and I think we'll actually do a while first. So while let's see, what should we call this? While interval is less than or equal to 30, so while that's true, I want to print calories burned in, and then we'll output the interval. I'll show you how we'll handle this in just a moment. And then the word minutes. And then I believe it's just a task of multiplying the calories burned per minute by the interval. Okay. We'll define interval. We'll start off at 0. Of course, we could start off at 5, because that's the first interval. And then, using shorthand assignment operators, or let's see what it would be without shorthand, interval plus 5. And we're going to convert that to interval plus equals 5, which is the shorthand notation. And let's execute this. I think this might be all that we would need to do here. there we are. You'll notice that on the program it has no decimal places, and we should be able to simply format our floating point result here to let's see, I think comma F might do it. Let's try that. Ooh, comma F will not. Let's do comma F. Let's see. Let's try that. I don't know what it is off the top of my head. It's not that. Well, the dot and the decimal. So I don't want there to be any decimals. It might, dot zero might just, oh, there we go. There we go. And if we take a look at the results, and I believe that is the same. So that would be one way of doing this using a while loop. Let's do the same thing using a for loop. For, and I'm just going to reuse the word interval, in the range, let's see, we want to start, let's see, where do we want to start? Do we want to start at 0? No, we'll start at 1. Oh, sorry, I'll try that again. Range. The range function. We'll start at 1. And we'll stop at 31. It always has to be one more than what you think, because this is exclusive, where the first argument is inclusive. So that would be 1 through 30 there. And we'll set the step argument as 5. And we'll basically do that. I said start it at 1, but again we'll want to start at the range 5. And I'm going to drop this off. Be sure to tab that in. And I believe this is all we would need for a for loop. So we're starting at 5, we're going from 5 to 30, and we're stepping or incrementing by 5 every time that we go through the loop, or every iteration of the loop. There we go. Looks like the same output. So notice that with the for loop and using the range function, we can set the beginning and the end, and we don't have to keep track of how many we've iterated. The loop will do that for us, whereas in a while loop, we do have to keep track, because we have to have some sort of condition that becomes false to drop out of the while loop. Alright, that's the first exercise. Let's move on to the second exercise. We'll call this one E2 underscore, I'm going to say cell to fair, or fa, I guess it would be table. Celsius to Fahrenheit table, in other words, .py. Alright, let me close that. Write a Python program that displays a table of Celsius temperatures 0 through 20 and their Fahrenheit equivalents. The formula for converting, and we've done a program similar to this in a past exercise. So this is exercise 2, Celsius to Fahrenheit table. Alright, well, let's do the first part. Let's print out the purpose of the program, or at least the description of it. Celsius to Fahrenheit table. And we'll do a new line character here. Anytime you see data in columns like this, it implies the use of a tabbed character. So just FYI. So we're going to print the word Celsius \t, which is the escape sequence for a tab character and the word Fahrenheit. And underneath that, we'll print as many dashes as the word Celsius has, and then another tab character, and then as many dashes as the word Fahrenheit has. Let's go ahead and run this really quickly. I want to see what it looks like on output. Okay, I guess it's going to be 2 tab characters, not just one, because one tab just looks like there's one space of separation. Let's try 2 tabs. Yeah, that's better. So I require 2 tabs. Again, we could use a while loop, but it does specify starting at 0 through 20. So I'm just going to use a for loop. Let's say for, I'm going to call it for temperature in the range 0 through 21. Remember, it has to be one more because this number is exclusive, so it goes 0 to 20, colon. Let me go ahead and write my comment to end the for. Not that that's required, it's just something I like to do. So the first thing I'll do is print out temperature, because that's going to tell me my Celsius temperature. And I tell you what, let's just run that and see what it looks like. And it should do a nice list upon the left of Celsius. There we go. 0 through 20. So now all we got to do is do the Fahrenheit part. Now there's going to be at least 2 tabs. I'm thinking there might be 3 tabs in here. We'll just have to try it to see what the output looks like. So I'm going to put in a couple of tabs, and then I'm just going to write the formula directly in the print statement. Don't have to do it this way. You could assign the results of this formula to a variable. I'm just going to save some time and do 9 divided by 5 multiplied by C, which is going to be the temperature variable, because it starts at 0, then 1, and then so forth. And then we're going to add 32 to that. And if all goes well, that's pretty much all we have to do here. Excellent. And it looks like we have accurate data. 0 Fahrenheit is indeed 32 degrees. Or, I'm sorry, 0 Celsius is indeed 32. And I think the easiest way to make sure that I've done this correctly is instead of stopping at 21, let's go to 101, because 101 should be the boiling point of water in Fahrenheit. It's like 2, yeah, something like that. Alright, now we do have some decimal problems, and we can quickly fix that by format the results of that equation to, looks like, .1f, or 1 decimal place. Let's make sure that still runs properly. Good. And that is this exercise. Fairly straightforward one, and pretty fast to write. Of course, we're not asking for any input from the user here. Just outputting or calculating information. A big note here is to notice that I created the separation using the escape sequence for the tab character. Alright, the third program is the sum and average of numbers. So we'll do E3 underscore sum, and I'm just going to do AVG for average of numbers. .py. Can't forget the .py. Alright, I'm going to close these. Well, let's read this one. Write a Python program. Write a Python program with a loop, okay, that asks the users to enter a series of positive numbers. The program shall enter, or rather the user shall enter a negative number to signal the end of the series. After all the positive numbers have been entered, the program shall display their sum and the average. All right, well, this is exercise 3. Sum and average of numbers. All right, let's output the program's purpose or description. This program sums and averages a series of user-entered numbers. It's kind of like a grading program. And we'll just, let me do a new line character at the end. And then we tell the user to enter a negative number to stop. And then we'll do another new line. So I don't know how many times I'm going to loop through. So let's say while. There's a couple of ways we could do this. We could say while true, and then check for a negative number and break out when we hit a negative number. But let's do it probably the more robust way, let's say. We'll ask the user for, I'm just going to call this variable number, and it doesn't say that it has to be integer numbers, but we'll just go with integer numbers. We'll ask the user to enter a number, :space. While number greater than or equal to 0, so it's enter a negative number to stop. Alright, so we want to do that. While number greater than or equal to 0, let's see, and let's create a variable out here called I'm going to call it total, set it equal to 0. So while number, and we'll do total plus equals, which is the equivalent of total plus number. Remember, we'll do the shorthand assignment operator here. So plus equals number. Drop that out. All right, let me see if we got this right. Okay. We'll do another variable called count, or counter, I guess I should do, to hold the number of hold the number of iterations through the loop. That way we know what to average by. And then we just have to ask the user for another number. I think this is all we need here. We'll do some tests to make sure it doesn't have any anomalies. This, by the way, is called a priming read. This will let the while loop know at the very beginning, because if the user enters something like -5 to begin with, there's no reason to go into the while. Although, if they did do that, and that would not total up. So I am going to put the while, although we're going to have to define number. Alright, I'm going to take it back to where it was, and I'm just going to try this once. Let's see what it does. Alright, so let's do 190, and then I'm going to enter -1. Alright, well, that doesn't really tell me much because I actually need to do the sum and average so I can actually see what the results are. So let's do sum of numbers, colon space, oh, sorry, no colon space here, comma, and we'll just call it total. And then we'll print average of numbers, I forgot that up there, colon, comma, total divided by counter. Should tell me that data. Let's try this one more time and see what it gives me. Let's do 190, and we'll do -1. That should return 95. And it does return 95, just as I would expect. Do a new line there. The problem is, and you'll see this, if the user enters one number and then quits, oh, no, it still works. Perfect. Oh, that's it then. We'll do what the example has. We'll do 100, 90, 80, 70, 60, 50, and -1. That should return, what, 75 as the average? There we go. Notice that my total does not have a decimal point, and I'm assuming that the reason that is because when I converted that to float instead of integers, which is probably more robust programming. 100, 90, 80, 70, 60, 50, -1. And there you go. There's that program. Cool little program. This -1, just so you know, it doesn't have to be -1. It could be any negative value. That's called a sentinel value. That lets the loop know to stop asking the user because it is outside the range of possible values. And unless you have a teacher that's cruel, assuming that this is for grades, then you can't have a number or a grade value that's less than 0%. You can't have less than 0%. That's the end. Although I'm sure some teachers will try to give students negative percentages. It's not very logical, though. Let's move on to the fourth program. So, excuse me, we'll create a new file, and we'll call this one E4 _ sum of range. And we wrote this one in class today. And I gave it a very high number, and it took, let's go with 20 to 30 seconds before it was able to calculate it. It's a short program, but it's a cool one. All right. Exercise 4. Write a Python program that asks the user for a number greater than 1 and validate that. So that's actually the first thing that I want us to do. So this is exercise 4. Sum of range. So let's output the program's purpose, or the description of it. This program calculates the sum sum of all integers in a range from 1 to a user specified number. And we'll do a new line character, as always, at the end. And then we're going to ask the user to enter a number. It does need to be integer, so number equals integer input, and we'll just ask them to enter a number, colon space. While number, let's see, less than or equal to 1, I'm sorry, not less than or equal to 1, number greater than 1. Okay, so it is less than or equal to 1. Although, let's go with 0. Number less than or equal to 0, because if you take a look, it does say here value must be greater than 0. It doesn't say anything about being greater than 1. So we'll go with that. While number less than or equal to 0, we will ask them to enter the number again, but first we will tell them, and by them of course I mean the user, value must be greater than 0. And then we'll ask them to enter the number again, and continue to ask them until they give us a good value. And that is a value that is 1 or greater. Let's see this in action. Alright, so if they enter a number like 0, we ask them again. Something like -1, we ask them again. It's only until they enter a good value, like 5, that the program continues. This is called input validation, and it is very important. It goes to the principle of GIGO, garbage in, garbage out. If the user does not give us good data or good values, then our program is not going to produce accurate information or accurate data. So that's my input validation. And now what I want to do, and I'm actually going to write the print statement for the bottom. Total of integers between 1 and the value that they enter, which will be called number, and then colon. I'm going to go ahead and pass the sep argument, so we'll need a space there. Alright, I'm going to go up here above number and create the total, a total variable, and set it to 0. And then after this we'll do total. So that gets that set up. Now I just got to implement the logic. Because I know how many times I'm going to loop, this suggests a for loop. So that's what we're going to do here. For I don't know, we'll go with value in the range function, starting at 1, going to the number that the user entered plus 1. Otherwise, it would go to 1 less if I just include the number they enter. So I want to go 1 more than that so that it gets that number. And all we have to do is set the total plus equal to the value of the loop. So the first time through the loop it'll be 1, and then 2, 3, 4, and however many times they go through the loop. We'll do a simple one so it doesn't take long. We'll do a simple one first. Let's do 100. Oh, I do need a new line character. And you'll see that that is the result, and it is accurate. Let's do a new line character right before the total. And I'm going to format. I'm going to format the total so that it has commas properly. And because it's an integer, it's the letter D instead of an F. Alright, so that was 100, and it produced accurate output. Let's do 100,000. 1, 2, 3, 4, 5 zeros. There we go. And I think that was one of the examples. Oh no, I went 2019. Let's see, let's do 2019 then. $2,039,190, and that's accurate. Alright, so we did 100,000. Let's do 100 million. Okay, that's 100,000 and the hundreds place. Now, this one will take a second. So, think about what's going on here. I'm adding 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 all the way up to 100 million. And I'm running this inside of a virtual machine, so it's going to take you a little bit longer. It only has access to 2 processors, and it's only working on one of them. While that's working, let's take a look at the next. Oh, did I do it? There it is. So that's, let's see, 100,000, million, billion, trillion, whatever comes after trillion. I'm not sure off the top of my head. It's interesting that it's almost even except for the 50 million there. It's almost even, right? Alright, the 5th exercise has you do a program that calculates factorials. And I'm not going to write this one for you. This is going to be one that, based on what you've learned thus far, that you guys can write on your own. It's not too difficult. The only difficult thing is making sure that you use the end equals an empty space so that you can print out all this on multiple lines if you need to. You don't necessarily have to, but it will make it easier. And again, just make sure that the user doesn't enter a non-negative number using input validation like we've done here. And so yeah, there are 4 of the 5 exercises using loops. If you have any questions, feel free to shoot me an email as always. But I'm going to bring this video to an end. I hope you have a fantastic rest of the day.